Welcome to the deep dive. Today we're getting into something that, well, it fascinates pretty much everyone and maybe makes us a tiny bit anxious sometimes. Air travel safety.
Absolutely. It's just a huge technological marvel we often take for granted.
Exactly. Every single flight, it's this incredible mix of engineering, human skill, complex systems working together. But, when something does go wrong, bang, it's all over the news.
It dominates the headlines, understandably.
So today we're exploring the main reasons behind plane crashes. We'll look globally and then we'll kind of zero in on India's specific situation.
Which is a really interesting case study, given the growth there.
Right. So our mission for you today, we want to quickly, clearly just pull out the key insights from the courses we've looked at, give you that shortcut to being genuinely informed.
Yeah, not just the surface level stuff.
We're aiming for those aha moments, helping you understand not just what causes these rare accidents, but also, how safety is constantly being worked on, improved.
And that continuous improvement aspect is so important. It's crucial to look past the drama and see the really robust safety layers involved.
Definitely.
Because the reality of aviation safety, if you really look at the numbers, it's often quite surprising compared to how people feel about it.
That's a great place to start, actually. Think about it. Thousands upon thousands of flights every single day, taking off, landing, perfectly safe.
It's phenomenal, really.
It makes flying, statistically speaking, the safest way to travel, by far.
It really is.
But, like you said, despite that amazing record, when an accident does happen, it's deeply tragic, and it absolutely grabs our attention, raises concerns.
Of course, and rightly so.
And for you listening, understanding this becomes even more relevant when we talk about India. It's one of the fastest growing aviation markets anywhere.
Exploding, really.
So its journey, scaling up safely, offers some really unique lessons. So the big question is, what are the main reasons these rare but obviously huge impact crashes still happen?
Yeah, how do they happen with all those safety nets?
Yeah.
Well, that's the core of it, isn't it? The overall record is amazing, but digging into the why and the how when things do go wrong, even rarely, that's absolutely fundamental for making things even safer.
Okay.
Flying safety isn't luck. It's built on super strict global rules, constantly evolving technology, and, incredible human expertise. Pilots, controllers, maintenance crews.
A whole ecosystem.
Precisely. It's a dynamic process.
Yeah.
Every single incident, even minor ones, gets analyzed to death to stop it happening again.
Okay, right. Let's unpack this then. Our sources, they seem to point to about 5 main areas, 5 big causes for crashes, globally and also in India.
That's a good way to categorize them, yeah.
And the first one, well, it often surprises people, especially now with planes being so automated.
Pilot error. It's almost always at the top of the list,
Yes.
statistically.
Pilot error.
But it's really important to understand what that means today. It's usually not just, basic flying mistakes like in the old days.
Yeah.
More often, it involves really complex decisions made under intense pressure, or maybe errors in managing the automation itself, the flight computers, or issues with what we call crew resource management, CRM.
CRM, how the crew works together.
Exactly. How they use all the resources available, technology, procedures, each other, air traffic control. It really highlights that interface between the human and the machine. Even the best pilots are human, and in unique, high-stress situations, mistakes can happen.
That makes sense. It's managing the whole system, not just flying the plane by hand. That really changes how you think about it.
Okay, so beyond the human element, sometimes the machine itself is the problem, right? Mechanical failure?
Yeah, but that's the next major category, mechanical failure.
What does that usually look like? Is it engines exploding?
Sometimes, but often it's maybe more subtle. Even with incredibly strict maintenance, parts can fail. It might be something like metal fatigue, a tiny crack growing over time,
Well,
or maybe a glitch in a complex avionics system, the plane's electronics. Could be software, could be, I don't know, unexpected interference. Right.
What's really interesting now is the push towards predictive maintenance.
Yeah.
Using sensors, data, trying to spot potential problems before they become critical.
So trying to get ahead of the failure.
Exactly. It's this balance between human checks and letting the technology monitor itself.
Got it. Okay, human error, mechanical failure.
Yeah.
What about things outside the plane, like Mother Nature? Bad weather must play a part.
Oh, absolutely. Bad weather is a significant factor. And we're not just talking about a bit of rain or fog, usually.
No.
We mean severe stuff. Thunderstorms generating microbursts, these sudden violent downdrafts.
Right, I've heard of those.
They can push a plane downwards dangerously fast, especially near the ground during takeoff or landing, or wind shear sudden changes in wind speed or direction.
That sounds tricky.
Very. Dense fog obviously cuts visibility right down, makes landing reliant on instruments. It just shows that constant battle against the environment. You need sophisticated real-time weather radar, other tech, just to plan flights and make decisions in the air.
Okay, so human, machine, weather. Then there are these like unexpected external things, wild cards.
Yeah, external factors, things you can't easily predict.
Yeah.
The classic example is a bird strike.
Ah, birds, really? They can bring down a plane.
They absolutely can, especially if they get sucked into an engine, particularly during takeoff or landing when engines are at high power and the plane is low.
Wow.
And our sources specifically mention bird strikes being, well, quite prevalent in India.
Why India specifically?
It seems linked to a few things. Growing cities around airports, changing bird migration patterns maybe, sometimes even how waste is managed near airfields, which can attract birds.
Huh. So how do you even deal with something that random?
It's tough. Airports have wildlife management teams, sometimes use radar to detect flocks, try to make the area less attractive to birds. It's an ongoing challenge.
Right. Okay. Fifth category. Let's bring it back down to the ground. Air traffic control and runway issues.
Yep, ground control challenges. This covers a few things. Miscommunication is a big one. Pilot misunderstandings with air traffic controllers.
Leading to...
Could lead to runway incursions, basically. A plane or vehicle being on a runway when it shouldn't be. Or just misjudgments during busy approach or departure phases.
And the runway itself.
Runway conditions are critical too. If a runway's wet from heavy rain, or icy, or has debris, it seriously affects braking.
So planes could overshoot.
Exactly.
Yeah.
Runway excursions overrunning, undershooting, veering off the side. Especially at maybe older airports, or ones with geographical challenges. Keeping runways clear, well-lit, and having good guidance systems is vital.
Okay, that makes sense. 5 big areas. Now, you mentioned India earlier. This is where it gets really interesting, right? Because it's such a fast-growing market.
It really is. India's aviation growth is, well, staggering. But sadly, it has also seen several major accidents over the last couple of decades that really highlight these factors we've discussed.
Can you give an example?
Well, the Kozhikode crash in 2020 is a prominent one. It involved multiple factors.
Okay.
It was terrible weather, very heavy rain. And the plane, a wide-body jet, overshot what's called a tabletop runway.
Tabletop. What's that?
It's a runway built on a plateau, so
Yeah.
there are steep drops at the end. Very challenging geography.
Wow.
So that crash became a huge case study. Looking at pilot decisions in bad weather, yes, but also looking hard at airport infrastructure, runway safety areas, the space beyond the runway, and especially for these geographically tricky airports.
So it brought multiple issues to the forefront.
Exactly. And experts generally agree, while India has invested a lot in improving its aviation infrastructure, the sheer speed of growth means there's this constant need for upgrades, pilot training standards, real-time weather information specifically for airports, and just ensuring consistent safety standards across all airports, big and small.
Right. It's a constant catch-up game, almost.
In a rapidly expanding system, yes, you have to be relentlessly proactive.
So putting all this together, the human side, the machines, the weather, these outside factors, the ground control, what's being done? What does this mean for the future? How do we keep making flying even safer?
It means constant work, basically. A really integrated approach, driven by data. Safety agencies like the DGCA in India or the global body ICAO.
Right, the international organization.
They are always working on this. They set the standards, they investigate, they push for improvements.
And what do those improvements look like practically?
Well, it's not just more training, it's smarter training. Using incredibly advanced simulators, even VR, to put pilots in hyper-realistic situations, things that almost never happen but could.
Okay.
Is that predictive maintenance we talked about, using sensors and big data to fix things before they break.
Mm.
It's improving air traffic management, making routes more efficient, reducing chances for human error there.
Better tech on the ground, too.
Absolutely. And investing in airport infrastructure that can handle, increasingly unpredictable weather. All these things, these proactive steps, they are working. Crash rates continue to go down globally. Flying gets safer year after year.
That's really the key takeaway, isn't it? Despite the headlines, despite the focus when something goes wrong, flying remains remarkably safe.
It truly does. It's a testament to the systems, the technology, the people.
And hopefully, this depth dive has given you, our listener, a clearer picture, a more nuanced view of the how and the why behind those rare accidents, but more importantly, how the entire industry is constantly learning and improving safety.
Continuous improvement is the name of the game in aviation safety.
So here's something to think about as we wrap up. We've talked about those five main causes: pilot judgment and decision making, mechanical integrity, weather challenges, external factors like bird strikes, and ground control or runway issues. Looking ahead, say, over the next decade, which one of those areas do you think holds the most potential for really big, game changing innovation? Where could we see the next leap forward in making the skies even safer? Something for you to ponder.